All right, and here's our second discussion on negative exponents. We will be practicing this quite a bit. Remember that these are our two exponent rules right here. And what they're basically telling us is if our negative exponent falls in the numerator, it's going to move down to the denominator. And if it starts off in the denominator, it's going to move up to the numerator. Remember, this is for exponents only. Do not try these with negative numbers. So we're just going to work through a bunch of examples. Feel free when I switch pages to try them on your own before you watch me work them out. But if you are stuck, then please, I'll obviously go ahead and continue watching the video. The more practice you get, the better you're going to be. All right. So our first example here, remember we're only looking for negative exponents. So in this case, the only variable or number with a negative exponent is right here. Everything else is a positive exponent. 3 has a positive 1, b has a positive 3, and the a in the denominator is positive. All right. What I like to do as I'm doing them when they look like this is I just go down the line in the numerator and put everybody where they belong. Okay. So my 3 is positive, and so his exponent is positive. He's staying in the numerator. The a has a negative 2, so in order to change that to a positive 2, it needs to go in the denominator. And it is, oh, that's sloppy. Let's do that again. Okay. And he is down in the denominator. My b, my last thing in the top, is fine. He has a positive exponent. He's going to stay there. As I go to the denominator now, I only have one thing. It's an a, and it's to the 4th power. Okay. So that was my rules number, what I'm calling in classes 3 and 4. Okay, 1 and 2 were the product rule and the power rule. And now I have, the top is okay, the numerator's fine. I have a 3 and I have a b cubed. But in the denominator, I have 2 different a's. As far as exponents go, they're both positive now. This is where we're going to use the product rule, or rule number 1 if you are watching from a classroom, okay? And in between these a's is multiplication. Okay, so there's no addition and subtraction involved with this negative exponent rule. So that means that I have to go ahead, keep the base, and add my exponents, which in this case will give me a to the 6th. So my finished product is my 3 b to the 3rd in the numerator, and then combining my a's in the denominator, I have a to the 6th. And you are done. Now these will start to look weird the more variables and stuff we have hopping up and down across the division bar. But sometimes this is what you have and you're done with it. All right, let's go ahead and look at a few more examples. Feel free to stop and try them on your own before you see me do them. All right, so the first one is I have something in parentheses to an exponent. So when something is in a set of parentheses to some exponent, everything inside is attached to that exponent. In this case, my exponent is also negative, which means everything here needs to move to the denominator of a fraction to start off with. All right? So I draw my division bar. Everything here has to go in the denominator. And now my x outside, can't talk today, exponent is now positive. Because everything is in the denominator of a fraction, I can go ahead and just put a 1 on top to go ahead and notate that it's in the denominator of a fraction. All right. Now I have to go ahead and apply my rule number 2, or my power rule, to all the exponents inside. Okay, so my exponent on my 2 is 1, on my x is 2, my y is 3. So I have, in the denominator, I have negative 2 to the 1 times 3, which is negative 2 to the third power. And notice I'm keeping that negative inside the parentheses because it does go along with the 2. I have a y, or an x, to the 2 times 3, which is 6. And I have a y to the 3 times 3, which is 9. I'm almost done, but if you're here, you're pretty much almost all the way there. I now need to go ahead and take care of my negative 2 to the third power, which is negative 2 times negative 2 times negative 2, right? Which is going to give me a negative 8. So my final answer will be 1 over negative 8, and I'm okay with you leaving it in the denominator with the where you did it, x to the 6th, y to the 9th, and now you are finished. Okay? Let's go ahead and look at the next example. And I got quite a few of them that have negative exponents. We cannot work with them as negative exponents. Please just don't. Okay? Again, I'm going to go ahead and draw my division bar. I have no numbers here, so I won't have to do any multiplication. And I'm going to go one by one. So my b to the negative 2 power needs to move from the numerator to the denominator. My c is to the positive first power. It's going to stay. You can put the first power on there if you would like. Numerator's done. Denominator, I have a to the negative 3. Because it's in the denominator, it needs to move to the numerator and become positive. Notice I'm not worrying about the order. My b to the 4th power stays. And my c to the negative 1 is in the denominator, needs to move to the numerator. And I'm going to also go ahead and write its exponent. At this point, we're just going ahead using the product rule and combine my like bases. So on the top, switch colors here, I have a c and a c. So I have c to the 1 plus 1, which is c to the 2nd power. And then my a to the 3rd is the only a up there. I'm just going to go ahead and write them. If you have it the other way, c first and then a, it's totally fine. My b's, remember this is multiplication, I have a b on the bottom to the 2 plus 4, which is 6. And at this point, you're done, because you don't have any numbers where you actually have to go ahead and do the multiplication. All right. I'm going to go ahead and do this one. Again, same idea. I always kind of work them this way. It keeps it very systematic, and I don't lose anybody. So my 5 has a positive 1 power, so my 5 is going to stay on top. My a is to the negative 3, so I need to put it in the denominator and make it the exponent positive. Now in the denominator, I have an a to the positive 1. It's going to stay there. And I have a b to the negative 5, which needs to move up into the numerator as a positive exponent. Now my numerator is totally okay. My denominator, I need to go ahead and add my exponents. So I have 5b to the 5th power on the numerator, and then base a to the 3 plus 1, or a to the 4th. All right. I got one more here. This is a messy one. I'd love for you to try it. Remember, this only applies to exponents. Give it a try. take all the time you need, and then come back and watch me work it out. Right, this one's a little messier than some of our previous ones, but I'm not going to change my methodology here. So my 3 here is actually to a negative third power. Okay, so I'm going to go ahead and move it into the denominator. All right. My a is a positive first power. It's going to stay. My b is to a negative 2 power. I'm going to put him in the denominator as a positive. Oops. This should be a positive 3, not a negative. Apologies. I wrote the minus in there. You wouldn't write a plus in there, but just because I boo-booed. Now I have a 2 in the denominator to the negative 2 power. That's going to come up to a positive 2 power. I have an a to the negative 3, so it needs to come up as a positive 3. And I have a b to the first. It's positive, so it's going to stay on the bottom. Once you get all this done, it's a point of just going ahead and working the numbers and the letters out. I like to do the letters first. So I'm going to go ahead, start a new fraction. I'm going to keep my a here to the first power and a to the third. That's an a to the 1 plus 3, or a to the fourth. On the denominator, I have b to the 2 plus 1, which is b to the third. And my variables are done. Now I just have to do my numbers. All right, so I have 2 squared, or 2 times 2, which is 4. And I have a 3 to the third power, which is 3 times 3 times 3, which is 27. And I have taken care of all my exponents. Now, negative exponents produce fractions. Fractions always require us to go ahead and simplify each fraction. All right, and so these negative exponents will force you to use the idea of your fraction rules as far as simplifying. This example that I did right here, these do not cancel. All right, I will prove it to you really quick. If 4 is 2 times 2, and 27 is 3 times 3 times 3, which is what these mean, right? These are all prime factors, and none of them are alike, so nothing is going to cancel. All right, so this is in its simplest form. You didn't have to do anything for that. But what's going to come up is we're going to have to simplify these fractions. So let's go ahead and look at a simple example simplifying. We're not going to do a lot of this today. The next video will have a bit more of these for us to practice. All right. And I have a squared over a to the third, and I'm not even giving you negative exponents at this point. We just want to see how the simplifying works. If I have a squared, it's the same as saying a times a. If I have a to the third power, that means I'm taking a and multiplying it by itself 3 times. Now, from our fractions, we know if we have something alike on the top and something alike on the bottom, like 3 over 3, they, quote, cancel and become 1. Right? So the idea is the same with the variables. If the letters are exactly the same, they're going to cancel each other out and become 1s. 1 times anything is not going to change the value. So every pair of a's, one in the top, one in the bottom, we can cancel out and simplify that way. So here I have an a and an a. They cancel out. It has to be one top and one on the bottom. Here I have another a and another a. Now I'm left with one a in the denominator. Remember when these a's canceled out, they became 1. And so this simplifies into 1 over a. So like I said, we're not going to do a bunch with this today. We are going to work on this in the next video. So go ahead and work on the practice problems, and I will see you then.